Alright, so you're going to look at the circuit theorems, and what we focus on in this tutorial is the linearity principle or property. Okay, maybe before we even go, maybe before we start answering this question, we'd also love to understand the background, like the description of the linearity principle. Okay, so what is it all about? Okay, so what we need to understand is that the linearity property, okay, the linearity property describes the linear relationship between the cause and the effect. Okay, so it's more like you are saying describes the relationship between the cause and the effect. Okay, so the relationship between the cause and the effect is the one that is described by the linearity property or principle. And this is more like, let's say for example we have the input here. Okay, we have the input and we have the output here. So what describes the relationship between these two? And of course it's not just any other relationship. This is a linear, okay, this is a linear relationship that we are trying to bring on the table here. Okay, so it is when you read through some content, you'll be told that this principle, this property is based on two is also based like on two properties, which is one that is indicated as a homogeneity, um, homogeneity, as well as the additivity. Okay, additivity property. So what are we able to understand from the homogeneity and additivity property is that from the homogeneity property, it states that it requires that the input, if you get the input, you multiply it by a certain constant. If you multiply the input by a certain constant, the output is also multiplied by the same constant. So if we were to use, for example, if we were to use Ohm's law, where we have the voltage being equals to the current multiplied by the resistance. So if you multiply the input here, let's say I multiply the current by a constant of m. Okay, so meaning I also have to multiply the output that I'm going to get on voltage there by m. So meaning I'm going to have, if I say mir will be equals to mv, like that. Okay, so that is what homogeneity talks about. Then for additivity is talks about, say the response to a sum of input is the sum of the responses to each input applied separately. So like for example, if you have something like if you have a voltage n, okay, if you have a voltage n being equals to in multiplied by r, okay, then we have another voltage m being equals to im multiplied by r. Okay, so this can be written in this manner, where I have voltage, okay, voltage being equals to voltage being equals to im plus in multiplied by what, multiplied by r here. All right, and this just indicates to say what you're going to have is simply what, is simply vn plus vm. Okay, plus vm there. That's what the additivity property talks about. Okay, so from the definition point of view, it's very important that we understand it from there, because that's where most of the questions are based. Okay, and in this case, we are told to say, for the circuit below, we make an assumption to say, okay, let vo be equals to 1 volt. Then we have to use the linearity property to determine the actual value of vo. So meaning the actual value of vo is not really 1 volt, but we want to make an assumption to say, okay, now what if it was 1 volt? So what we need to understand is that when you're given the vo, it's like you're making an assumption. Basically, it means the supply voltage here, instead of us having 15, is going to be some value. Okay, it's going to be some value, so we'll use that to compare, to say, okay, now if I have that value, let's say if I'm saying my vo is equals to 1, meaning my supply voltage is going to be equals to some value here. Let me just indicate it using x. Then initially we are given that the supply voltage is 15, so we would want to find what is here as the m, meaning the actual value of what, the actual value of vo when the supply voltage is 15. So here first of all we have to find what the supply voltage is when the vo is what, when the vo is 1. Okay, so here we have to do a lot of we are going to apply a lot of laws. Okay, so first of all what I would want to do is that to make things easy for myself, I would love to name this as my, let me say this is my I1. Okay, I have my I1 here, okay, going in that direction. Then let me say I have my I2 here going in this direction. Let me say I have my I3 here going in this direction. We say we have our I4 going in this direction, and we have our I5 going in that direction. So meaning I have five currents in this case, from 1 to 5. So if I'm able to find my I1, okay, if I'm able to find my I1, it will be very easy for me to find my supply voltage here. But of course, you can say we already have a 15, but that's not the case. It's the fact that I've made an assumption that my VO is equals to 1. So I want to try to find what my supply voltage is when VO is equals to 1. Okay, so what do I really mean by us having I1, making it simple? Remember to say from Ohm's law, you're going to say if at this point, okay, if at this point here, if at this point we say this is let me say this is V1, okay, let me say this is V1 there. We're going to find that by Ohm's law, our I1 will be equals to our supply voltage Vs minus our V1 divided by what, the resistance there, which is the resistor, which is 2. So if we find our I1, we find our V1, it will be very easy for us to find our Vs. And if we find our Vs, meaning the only thing remaining now is to find the actual value of Vo. Okay, so let's keep in mind that formula there. We need it. So the question is that how do we come up with the V1, because you have understood to say the most important variables that we need is the I1 and the V1. So how do we come up with those? First of all, we have to find what we have to find what most of these currents are here, so that we will apply KVL, I mean KCL, not KVL, yeah. We apply KCL here to find what I1 is. So I've noticed here, since I have my I4 at this point, I have my I5 at that point, it's very easy for me to find my I4 and my I5, and the I4 and I5 will help me find my I3. Okay, will help me find my I3 there. So what I'll do here is that I'll say my I4, okay, my I4 will be equals to my VO divided by the resistance there, which is what, which is a 6. So here when I look at this part here, okay, just remind ourselves this part here is one node, hence see that's where the reference node is indicated there. So that's just one node there. So remember to say that the reference node voltage is equals to 0. So we're going to say we have said our assumption that we have made an assumption to say VO is 1, so we divide by 6 there. So I found that our I4 is equals to 1 over 6. So we need to find out what our I5 is. So to find our I5 is also much easier. So you can say our I5 is equals to our VO divided by what? Divided by some current here. I mean some resistance. Some resistance. And what resistance do we have? We have this one and we have this one. They are in series, meaning we're able to add them together, giving us what? Giving us a 6. So it basically means even the I5 is also equals to what? 1 over 6. So now we begin our journey going towards the left side. Okay, so what we do here is that we are going to apply KCL. We're going to apply KCL at that node here. If you say this is node 2, let's say this is node 1, and say this is node 2 here. So if we apply KCL at node 2, we are going to find that your I3, okay, your I3 is equals to your I4 plus your I5, okay, plus your I5 there. Remember to say the current that enters a node is equals to the total current that leaves a node. So meaning this the sum of all the currents entering and leaving the node sums up to 0. So here we're going to say our I3, by the way that's what KCL states. Our I4 we found that is 1 over 6 plus our I5 is 1 over 6 as well. So meaning our I3 will be equals to uh, I think this would be 1 over 3, because you're going to have 2 over 6. 2 into 2 1, 2 into 6 is a 3. So we have found that our I3 is equals to 1 over 3. So we are getting closer and closer to the answer that we are looking for here. So of what use is I3? Remember to say, if I have my V1 here, okay, if I have my V1, perhaps things will be much easier. And we're able to find, I believe, looking at what we have here as our I3, um, we're able to find what are we able to have to find at this point. I think we're able to use it to find what V1 is, because we know that our I3, okay, our I3 is equals to our V1 minus our VO divided by what? Divide by the current there. Why do I keep on saying current? But resistance rather. It's 3. So our I3, we have found that our I3 is 1 over 3 is equals to our V1 minus our 1, which is the VO. We have a 3 there. So what you're going to find is that your V1 will be equals to what? Will be equals to 2. When you do the cross multiplication, the 3, okay, let's just say the 3 goes, then the 1 goes on the other side, becomes positive, meaning we have a what? We have a 2. So V1 is equals to 2 volts. Okay, so now, remember to say, for us to find I1, our I1 using KCL, our I1 is equals to our I2 plus our I3. We have our I3. We don't yet have our I2. How can you find our I2? We know that we can say our I2 is simply equals to V1 divided by what? The resistance, the resistor there, which is what? Which is a 6. So this is equals to 2 over 6, giving us 1 over 3. So our I2 is equals to 1 over 3 amps as well. So uh, then we are able to find the we're able to find the I1 now. So I can say our I1 is equals to our I2, which is 1 over 3, plus our I3, which is 1 over 3 as well. So hence this gives us I1 being equals to 2 over 3 amps. So I1 is equals to 2 over 3 amps there. So I bet now we're able to find what our supply voltage is when we have made an assumption that VO is equals to 1 volt. So we know that our I1 initially is, by Ohm's law, is equals to our supply voltage, I'll say Vs, minus V1 divided by the resistor, which is there is what? Which is 2. So the I1 is simply the current that passes through the resistor 2. So we have our I1, which is equals to 2 over 3 is equals to our Vs minus our V1 is equals to a 2 divided by 2 there. So we are going to do the cross multiplication there, or I'll just multiply these 2 on the other side. So meaning I'll have my Vs minus 2 being equals to 4 over 3. So I'm going to add 2 on both sides. Okay, I'm adding 2 on both sides, so I'm going to have my Vs here being equals to making this a single fraction. You're going to find that if you have a 1 here, meaning this would be 4 plus 6 divided by 3, giving us 10 over 3. So we have found that our Vs is equals to 10 over 3. So what this simply means is that if VO was 1 volt, it could have meant that our supply voltage is what? Is 10 over 3. Okay, is 10 over 3. I don't really feel like putting it in decimal places. I'll just leave it the way it is as a fraction. So now we now know that when VO, okay, when VO is 1, our Vs will be equals to what? Will be equals to 10 over 3. But we want to find what the actual VO is when the supply voltage isn't 10 over 3, but it is what? When it is 15. So here it's more like you're saying it's X here like that. So what you do here is that you're going to say you have 10 over 3, X is equals to 15. You just divide both sides by 10 over 3, of which X will be equals to um, your value of X will be equals to 15 multiplied by 3 divided by 10. That will give us, if you say 15 by 3, that is 45 divided by 10. That will give us um, 4.5. So meaning the actual value of VO is simply what is simply 4 over 5, I mean 4.5 volts. So this is how we go about answering this question. Of course, there are perhaps multiple methods that you're able to use to answer this question, but this is one of the simple ways that you can use to go through this question. So it's just a matter of you having that assumption to say, okay, now my VO is this. Then you find what the supply voltage is when you have that value of VO, like because this VO. Remember to say we have resistors here, okay? We have resistors here. We had voltage drops across these resistors. So meaning the VO being one, it all came from the supply voltage. We were just breaking it down as a voltage was passing through the resistors. So this is how you go about this question. Thank you very much for watching.